Hey everyone, so um, I'm covering some basic laws of chemistry class 11 cbse, but this time I'll be using Claude to help me understand these concepts. In my previous live stream, I left with um, Avogadro's law. I think did I cover this section polyatomic and diatomic? Each box contains each number of. I think I did not cover this part. And to be honest with you, I still don't understand these laws very well. So it's going to take me some time. So I don't want to spend too much time dwelling on one concept. I'll move forward with other topics, and as I'm spending more time with these problems and concepts, fingers crossed, I hopefully learn or at least understand a little bit what these laws are about. But my first priority is to finish this chapter, and then if needed, then I'll again revisit the concepts and the problems and my notes which I've prepared. So I'll move on to the next topic, which is Dalton's atomic theory. Okay, so Dalton's atomic theory. So, although the origin of the idea that matter is composed of small indivisible particles called atomoto, meaning indivisible, date back to the time of Democritus, a Greek philosopher. It again started emerging as a result of several experiments studied which led to the laws mentioned above. Dalton published a new system of chemical philosophy in which he proposed the following. Okay, so what is the first law? Matter consists of indivis, um, indivisible atoms. Okay, all atoms of the given element have identical properties, including identical mass. An atom of different element differ in masses. So all atoms of all atoms of a given element have identical properties, including identical mass, and atoms of different elements differ in mass and also properties. Compounds are formed when atoms of different elements combine in a fixed ratio. Compounds are formed when atoms of different elements combine in a fixed ratio. And the fourth one is chemical reaction involves reorganization of atoms. They are neither created nor destroyed in chemical reaction. So this law proves law of conservation of mass, law of definite proportion, but this law failed to explain the law of gaseous volume. Chemical reaction involves the organization of atoms These are neither created nor destroyed in a chemical reaction. So Dalton theory could explain the law of chemical combination, however, it could not explain the law of gaseous volume. So I can write something like why Dalton's atomic theory failed to explain the law of gaseous volume. So I'll ask this question to Claude, but not right now. Now the next topic is atomic atomic masses and molecular masses. After having some idea about terms such as atoms and molecules, it's appropriate here to understand what do we mean by atomic and molecular mass. The atomic mass or the mass of an atom is actually very small because atoms are extremely small. Today we have sophisticated techniques, example mass spectrometry, for determining the atomic mass fairly accurately, but in the 19th century scientists could determine the mass of one atom relative to another by experiment means, as has been mentioned earlier. Hydrogen, being the lightest element, was arbitrarily assigned a mass of 1 without any unit, and other elements were assigned masses relative to it. However, the present system of atomic mass is based on carbon-12 as the standard and has been agreed upon in 1961. Here, carbon-12 is one isotope of carbon and is represented as 12C. In the system, 12C is assigned a mass unit of 12 atomic mass unit, and mass of other elements are given relative to this standard. So is defined as mass exactly equal to 1/12 of the mass of one carbon atom. So here this paragraph is trying to explain that since back in the early days they didn't have a way to calculate the mass of an atom since they're invisible and extremely small. So they arbitrarily assigned hydrogen 1 and other molecules weight or mass was defined relative to hydrogen. But now it's completely different. So the mass of one atom is equal to the 1/12 of the mass of carbon 12. So here what they're trying to say is that you have 12C. This is isotope of carbon. Okay. Now they're saying that if you divide it into, this is 2, 4, then 1, 2, 3, 4, 5, 6, then again this is 8, um, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need one more line. So I haven't drawn these section equally, but The point is, if you divide carbon 12 into 12 equal parts, 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, and if you take one part, the mass of that one part is equal to mass of one atom. So that's how they have defined it. Can I draw something in this? So here mass of 1/12 of carbon 12 isotope is equal to mass of one atom. And the unit is AMU, but now it's no longer used. So 1 AMU, that is mass of 1/12 of carbon 12, is this much. So mass of an atom equal to 1.66056 times 10 to the power minus 24. Okay, grams. You can also say this is the mass of 1/12 of uh, carbon 12 isotope. But now mass of hydrogen equal to 1.6736 times 10 to the power minus 24 grams. So you can also convert this gram into AMU. That is mass of one atom, or I should say 1 AMU, or over here I'll say equal to mass of one atom. So you can also find the mass of hydro. So what is the mass of hydrogen in AMU? So I know that 1 AMU equal to 1.66056 times 10 to the power minus 24 gram. So x AMU equal to 1.6736 times 10 to the power minus 24 grams. So here the value of x equal to 1.6736 times 10 to the power minus 24. This is point divided by, I'll just copy this. So the value of x turns out to be 1.0078 AMU. So I'll ask Claude if my understanding is correct. Right now the Claude that I'm using, the subscription one, is not working. Understanding correct. Yes, that's correct. Both the method and the arithmetic. Your setup is right since one AMU is defined as you find out how many of those units will do mass. Note for clarity. Technically, what you calculate is the mass of one hydrogen atom in AMU, not mass of hydrogen. In some more general sense, not the molar mass. That's nice feature of the AMU, not a coincide, but worth knowing that conceptually different quantities. Okay, I think I was about to read this in my next topic. Okay, so average atomic mass. Many natural occurring elements exist as more than one isotope. So carbon exists in three forms: carbon 12, 13 and 14. So what do you do in that scenario? So the average atomic mass of the element can be computed. Similarly, average atomic mass of other elements. So average atomic mass, do they only exist for uh, elements with isotopes? Do they only exist for elements with isotopes? Every element technically has an average listed on the periodic table. Elements with only one natural called monoisotopic element. They are technically still an average, but since the abundance of that one isotope is 100%, the average atomic mass is equal to the mass of that single isotope. Elements with no stable isotopes at all. Of the transuranics like plutonium, there is no natural abundance to average over since none occur naturally in fixed proportion for these elements. So the short answer is the weight average calculation specifically requires multiple isotopes. But the listed atomic mass, so give the atomic mass of elements in gram till zinc. I think I'll ask around two whole numbers. I should say also add another column which display their atomic weight in whole numbers. Lithium, a couple worth flagging as slightly deceptive, and lithium is indeed the dominant isotope. Chlorine rounds to 35 and chlorine is more abundant isotope, so this lines. Okay, so I'll copy this. I think Z over here represents the number of protons. मेरे को इतना याद है. ये कहाँ गया मेरा? Yes. I'll copy this and paste it somewhere. I think after my atomic masses. Uh, थोड़ा सा टाइम लग जाएगा इसको फिक्स करने में. इसको मैं बाद में ऑफ स्क्रीन फिक्स कर दूंगा. तभी के लिए ऐसे रहने देता हूँ. ठीक है, मेरे पास एटॉमिक मास हो गया. इसने यहाँ पे एक पॉइंट बोला था कि तो क्या मतलब बोला, mass of hydrogen, mass of hydrogen is equal to, what do you mean that it is not mass of one? Has the same mass? I think there is a mix-up. I never said it's not the. Let me re-clarify what I actually meant, because I can see how that sentence was confusing. What you calculated is the mass of one hydrogen atom in AMU, not mass of hydrogen. In some more general sense, this is the mass of one. Your calculation is the mass of a single atom expressed in AMU units, opposed to something like molar mass of expressed in grams. I was distinguishing between the two. Your value was wrong. Okay, so molar mass is, you take 6.022 into 10 to the power 23 atoms and multiply it with their molar mass. For example, oxygen is 16 times. Now the next one is average atomic mass. ठीक है, मैं इसको क्या करता हूँ, नोट कर लेता हूँ एवरेज एटॉमिक मास, एंड you know ask Claude to give me some problems so that I can understand these concepts. But अभी के लिए मेरे को कुछ समझ में नहीं आया, तो तुम ऐसे एवरेज कैलकुलेट कर सकते हो. Average atomic mass, more than one isotope, when we take into account of the existence of these isotopes and their relative abundance. For example, carbon has following three isotopes with relative abundance and mass. ओके, एटॉमिक मास. तो मैं क्या करता हूँ, स्नाइपिंग में जाऊंगा और इसको कॉपी कर लेते हैं. So from the above data, the average atomic mass turns out to be, मैं क्या करता हूँ, मैं इस पूरे को ही कॉपी कर लेता हूँ. Okay, now molecular mass. Molecular mass is the sum of atomic mass of the element present in a molecule. It is obtained by multiplying the atomic mass of each element and adding them together. For example, molecular mass of methane, which contains. Okay, molecular mass में हम क्या करेंगे? You take each atom and their atomic mass and you sum them up. Some substances such as sodium chloride do not contain discrete molecules as they constituent unit. In such compound, sodium and negative are arranged sodium chloride as in a solution or a solid. Has three dimensions. It may be noted that in sodium chloride, one end is surrounded by six chlorine ion and vice versa. The formula the formula such as NaCl is used to calculate the formula mass instead of as in solid states. Okay, so I can say what is the difference between molecular mass and formula. Thus the formula mass of sodium chloride is atomic mass of sodium plus atomic mass of. तो क्लॉड से पूछते हैं क्या डिफरेंस है. This is subtle but real distinction, mostly about what kind of substance you're describing. Used for substance that exist as discrete molecule held together. Okay, bicovalent bond. Formula mass is used for substance that don't exist, typically ionic compound. अच्छा. Some substances like sodium do not contain discrete molecule. पता नहीं, जब सेम क्लॉड ने एक्सप्लेन किया तो समझ में आ गया, बट ये आई थिंक मैं दिमाग में ये लेके बैठा हूँ कि मेरे को ये जो बताएंगे समझ में नहीं आएगा क्योंकि ये बहुत बेकार एक्सप्लेनेशन कर देते हैं. तो उस केस में फॉर्मूला मास यूज होता है. फॉर एग्जांपल NaCl. There is no single NaCl molecule floating around in the solid. It's a lattice of real discrete particle exist. Yes, no, it's repeatable lattice. So in practice, the calculation method is identical according to subscripts. The difference is purely about what actually being described. अच्छा, तो since अब मेरे को पता लग ही गया है what is the difference between molecular mass and molecular mass में होता है the molecule exists independently. Example CH4. And formula mass is molecules do not exist discretely, I think is the right word. Discretely. Example NaCl. but note the method to calculate the mass remains same. तो हमारा पहला प्रॉब्लम आ गया है, कैलकुलेट द मॉलिक्यूलर मास. सो molecular mass for glucose C6H12O6, mole concept and molar mass. Okay, what is the difference between molecular mass and molar mass? I think next ये मेरा डाउट होने वाला है. ठीक है, तो मेरे को पता लग गया है. तो C6H12O6 मॉलिक्यूलर मास. तो मेरे को पता है एक कार्बन का है 12U, हाइड्रोजन का है 1U, एंड ऑक्सीजन का है 60. I'm taking approximate the whole number value instead of 16U. तो 6 times 12 is 72 plus 12 times 1, 84 plus 6 times 16. 6 times 16 कितना होता है? Okay, 96 plus 96 to 192. नहीं, मैंने कुछ गलत किया. ओके, 12 टाइम्स 6 कितना हो गया? 72 प्लस 12 84, यहाँ तक करेक्ट था. 16 टाइम्स, ओके 84 प्लस 96 है. मैंने एक्चुअली 96 टाइम प्लस 96 कर दिया, which is 180U. Okay, now I think this is the heart and soul of this chapter, mole concept. Atoms and molecules are extremely small in size, and their numbers, and even a small amount of substance really very large. To handle such large number, a unit convenient magnitude is required. Just we denote 1 dozen by 12 items, gross for 144. We use the idea of mole to count entities at the microscopic level. Mole is the seventh base quality. The mole symbol is the SI unit of substance. 1 mole contains exactly these many atoms. The number is fixed numerical value. When we express the unit per mole and is called Avogadro's number, the amount of substance symbol N of a system is a measure of number of specific elementary entities. An elementary entity may be an atom, a molecule, an ion, an electron, any other particle. It may be emphasized that the mole of a substance always contains the same number of entities. क्या मतलब हुआ? It may be emphasized that the mole of a substance always contains the same number of entities. What the substance may be. I think this point seems to be important. मेरा guess ये है कि अगर हम 1 mole of sodium ले या 1 mole of methane, they will contain the same number of atoms. What does this mean? My guess is 1 mole of sodium and 1 mole of कोई एलिमेंट लेते हैं. copper oxide will have the same number of atoms, which is Gadro's number. Close, but there's an important catch. You're right about the numbers, but not quite right about what the number is counting. 1 mole of sodium and 1 mole of CuO both contains exactly that part you guess is correct. Where it needs a fixed entity being counted is different. Is not the same unit. So you get 6, but each formula unit contain 2 atoms. So okay, understood. The atoms remain same, but the total atom count will be okay. So हमारे पास इतने CU and one CO has 2 atoms. So these are total number of individual atoms. In order to determine this number precisely, the mass of carbon-12 was determined by a mass spectra and found it to be equal to, knowing that 1 mole of carbon weighs 12 grams, the number of atoms in it is equal to. Okay, so now they're trying to explain कि कैसे हमें Avogadro's number मिला है. Is the formula unit. कुछ लिखा है यहाँ पे फॉर्मूला यूनिट के बारे में. Molecular formula. लिमिटिंग एजेंट सभी तो बहुत कुछ है. तो एक काम करता हूँ. I think I'll probably end the live stream here since मूल concept थोड़ा important है तो मैं बाकी concept भी इसी के साथ cover करना चाहता हूँ. So yeah, thank guys tuning for the live stream and I'll see you guys in my next video. GG.